It was like $60 though. I'm gonna buy Rocket League. I've heard it's really good. I've watched my buddy. What's that? It just looks. It looks like that fun kind of chaos. It's like car soccer. You know. I'm gonna be buying Rocket League as soon as I have some money. So. It's 20 right now, I think. I thought it was 20. Basically, I'm like, I'm gonna go hit BioLife, which is the plasma donation center in Bellingham, and I'm gonna donate for a couple weeks in a row, maybe get myself like $150, $200, and then Steam Winter Sale is gonna hit, and I'm gonna go buy all the things, and I'm gonna buy Rocket League, and I'm gonna buy Borderlands, Tales from Borderlands, and I'm gonna buy Minecraft Story Mode, and not a Fallout fan. I know. I just don't like. In general, I don't like first-person shooters or third-person shooters. So it's not really a. But here's the thing. Actually, I don't like Minecraft that much. I was gonna buy Tales from the Borderlands and Minecraft Story Mode, which are the Telltale adventure games. Telltale is delicious. So. I have Minecraft, but mostly it's so that I can play with Baxter and Wesley. They are Minecraft. Like most. I started the video to record the lecture, and then we talked about video games. Super important. Woo! Yay! Okay, so let's talk about reversing the condition. Reversing the condition simply means this. We want to know P of A given B, right? What is the probability of event given B? But the information we know is P of A, P of B, and the probability of B given A. Notice how those are not the same thing, right? Switching that condition changes the problem significantly. When you have the contingency table, it's fine because you're just looking at either a different row or a different column. But when you don't have all of that information, you can't do it easily, right? Like that. And the main type of problem that we tend to look at with this reversing the conditions are the results of drug trials. Because the fun thing about drug testing and disease testing is that every single time you test to see if you have a disease, there is a chance for error. There is a chance that you have the disease and the test will not show you have the disease. They call that a false negative. That's meaning that your test showed up negative, but you do actually have the disease. And then there's also what's called a false positive, which means the test shows that you have the disease, but you don't actually have the disease. Every single medical procedure you go through, like every time you go to the doctor and they run a little test to see if you have something or not, there is a chance that your test will be wrong, right? That it'll say you have the disease even when you don't, or that it will say you don't have the disease even when you do, right? How many of you guys have had those strep test throws where they take a Q-tip and they shove it down your throat? I was sick and I was quarantined, right? On my birthday. So you actually had a false positive? Yeah. Oh. And so rude. Having a false positive, there's like a 5% chance of a false positive on those tests. So anytime you take a test, and this includes like tests for big diseases like HIV and cancer and things like that, there's always a chance that when you take those screening tests that you're going to have a false positive, which is enormously aggravating, right? To have a false positive or. I got that. It took me a second. I get it. That is a little bit cruel. But I like that. I like that. So anyway, we're looking for P of A given B, but we only know these things. But we know from our formulas that P of A given B is the same thing as P of A and B and P of B. So we have some of the information needed, right? We have the denominator because we'll be given the P of B, but we have to find P of A and B. But that's okay because P of A and B is P of A times P of B given A, which is also information that we have. But notice that that P of A and B comes from the flipped condition. B given A, not A given B. Reversing the condition is the same as what? Oh, looking at the cabinet right above the sink. No, you gotta pull really hard. Like watch this one now. I flipped my finger. Stop it. Also, is that disturbing when knowing that fingernail can get all the way flipped over? No, stop it. Do not like that. So, reversing the condition. Number one, the most important thing is using the notation to say what we need, and then using the notation to say what we have, then creating a tree diagram to find all the other information that we need. It's not an intuitive process. That's what that first thing up there says, right? It is not an intuitive process. So understanding how all of the notation and tree diagrams work is really essential towards being able to answer these types of questions. So let's jump in and do it, okay? So a recent Maryland highway safety study found that 77% of all accidents, the driver was wearing a seatbelt. Okay? Accident reports indicated that 92% of those drivers escaped serious injury, defined as hospitalization or death. But only 63% of the non-belted drivers were so fortunate. So the question is, what's the probability that a driver who was seriously injured wasn't wearing a seatbelt? So here's what I'm going to task you to right now. Can you please take a second right now, using the probability notation, right? P of seatbelt, P of accident. And can you please write down what we're looking for and all of the information we have? So before we jump into this problem, I want you to use the notation, our probability notation, and I want you to write what we're looking for and all of the information that we have, given it in our probability notation, right? I want to know P of this is this. We're looking for P of this. Right? Take a couple minutes here and talk with people and talk to people about this. Write what all of those notations are. rewriting in like root do a problem. Normally I would do this type of problem on the whiteboard, but I'm like, doing it on the whiteboard doesn't really help us record it. Okay, like 30 seconds, and then we're going to write some things down. It is. Okay. Yeah, what if we lost all that talk about Rocket League, right? That would have been gone forever. You know, we have no record of it. So important. Right, that maybe the cancer screening that you got the other day, or you know, when you went and got HIV screened the other day, the positive test result you got might be fake. I don't want to give you like false hope. Right. Okay, so first things first. In terms of our notation, what is it we are trying to find? P of Kelsey. Not P of like not the probability of being Kelsey. Kelsey, what were you going to say? Well, tell me what A and B are. Okay. And now did you say A and B? Not correct. Because this is a conditional probability. Yes. So notice the way this is written. What's the probability that a driver who was seriously injured, right? Notice that this little bit right here is giving us a condition, right? We know that a driver was seriously injured. So that's our given condition. We're trying to find the probability that they did not wear a seatbelt. So I'm going to write seatbelt complement. Given that they were seriously injured. That's what we're looking for. The probability of seatbelt complement, they weren't wearing a seatbelt, given that they were seriously injured. Okay, because they tell us a driver was seriously injured. Here is a given condition. Someone was injured. What's the probability that they weren't wearing a seatbelt? You have seatbelt complement given seriously injured. Now, just because we have it up there, the formula for a conditional probability tells me that I need to find P of seatbelt complement and seriously injured over the probability of being seriously injured. Okay? This conditional probability following our formula tells me that I need to find the probability of being of not wearing a seatbelt and being seriously injured over the probability of being seriously injured. That right there is a direct application of P of A given B equals P of A and B over P of B. Right, that's our formula for a conditional probability. All I've done is just applied it to our current events. Outcome. Maybe a better word. This is what we're trying to find. Seatbelt complement given seriously injured. To find that, I'm going to do probability of seatbelt complement and seriously injured over probability of seriously injured. Let's look at the other information we have. So, a recent Maryland highway safety study found that 70% of all accidents, the driver was wearing a seatbelt. So that means that P of seatbelt equals 0.77. Agree? Because there's no information about people being injured up there. It's just that this many people wear a seatbelt or were wearing a seatbelt in an accident. Accident reports indicate that 92% of those drivers escaped serious injury. What am I trying to say here? Accident reports indicated that 92% of those drivers escaped serious injury, but only 63% of the non-belted drivers were so fortunate. So, given that they were wearing a seatbelt, 92% of them were seriously injured. So the probability of seriously injured, given they were wearing a seatbelt, is 92%. There. You're right. Yes. P of seriously injured complement given seatbelt. But only 63% of the non-belted drivers were so fortunate. Meaning, P of seriously injured complement given seatbelt complement was only 0.63. The probability they were wearing a seatbelt was 77%. The probability that they were not seriously injured, given that they were wearing a seatbelt, was 92%. And the probability that they were not seriously injured, given that they weren't wearing a seatbelt, was 63%. Notice that that's all of the information that we were given. I've just cataloged it in terms of our probability notation. We're going to do this several times. Okay. Now, were we given any of the information that we needed over here to solve our problem? Are any of these things over here what I need to solve this problem? No. Well, do I have P of not wearing a seatbelt and seriously injured? Like, is that one of these ones over here? No. Do I have the probability of being seriously injured? No. So our given information, we did not get anything that we can directly plug into this problem. What we need to do is construct a tree diagram to find these things. So let's use this information that we have right here to construct a tree diagram, okay? Notice that the two informations we have seatbelt or not seatbelt as given information. So that's our first event. Either seatbelt or seatbelt complement. And then for each of those, we have a branch of seriously injured or not seriously injured. What's the probability that I wear a seatbelt? 77%, which means the probability that I'm not wearing a seatbelt? 23%. Now let's go up to our first conditional probability. Given that I was wearing a seatbelt, what's the probability that I was seriously injured? 8%. So 8% that I was seriously injured. Given that I was wearing a seatbelt, what's the probability that I wasn't seriously injured? 92%. Given that I was not wearing a seatbelt, what's the probability that I was not seriously injured? 63%. And then the one up here is 37%. Yes, always multiply up the branches. No, because of the flipped condition. All of this tree right here represents a tree diagram where the seatbelt is the initial condition. Okay. In order to answer that question to just multiply up, we would need to have our first tree be seriously injured complement, and then our second tree branch being seatbelt and seatbelt complement. And we don't have any of that information, right? We don't know the probability of being seriously injured. We weren't given that, so I can't make a tree for that yet, unfortunately. We're making this tree to figure out the other tree. Exactly. That is exactly what we are doing. So we actually have enough down now that we can figure out these other things. So we need P of seatbelt complement and seriously injured. So P of seatbelt complement and seriously injured is going to be that times that. So that's this one here. This here is P of seatbelt complement and seriously injured. So that is 0.23 times 0.37. 0.08 what? 0.0851. I'm running out of space. This is the problem with doing it like this. But I don't want to erase part of it. 0.0851 is what you said? I'm going to write it up here. So this is up there. Okay, so we have half of what we need to solve the problem. Now we need to find what's the probability of being seriously injured. Well, we can look at our tree to find the probability of being seriously injured. What are the two cases up there where we can be seriously injured? With a seatbelt and without a seatbelt, right? So we have seatbelt and seriously injured, and we have without a seatbelt and seriously injured. So the two ways that we can be seriously injured were if we're wearing a seatbelt or if we're not wearing a seatbelt. And if we add those two probabilities together, we'll have the probability of being seriously injured. So we're going to take this tree, which is the probability of seatbelt and seriously injured, which is 0.77 times 0.08. Yep, because we're going down the tree, always multiply on the branches. What's 0.77 times 0.08? 0.0616. So probability of being seriously injured is 0.0616 plus 0.0851. So 0.0851 divided by whatever that is. What's 0.0616 plus 0.0851? .1467. So we have the two pieces of information we need. The probability of being not wearing a seatbelt and being seriously injured was 0.0851. The probability of being seriously injured was 0.1467. Now we divide. We have our answer. Someone's dividing that for me? .5801. That's it. Nicole. 0.0851 was what we got when we multiplied seatbelt complement times seriously injured, which is what this one here is. Seriously injured is that probability plus that probability. Seatbelt times seriously injured. Let me write this over here. So the probability of being seriously injured is the probability of wearing a seatbelt and being seriously injured plus the probability of not wearing a seatbelt and being seriously injured. So we took that probability and that probability and we added them together. And like I said, and what I've been saying like all chapter, is being fluent in this P of notation is really, really helpful for these type of problems. Digest that for a bit, right? We finished the problem, digest it for a bit. Let me know what kind of questions you have. So 0.0851 was this one, seatbelt complement and seriously injured. We divided it by probability of being seriously injured. How do we find this? We looked at the tree and said, what are all of the cases where we can be seriously injured? We can either be wearing a seatbelt and be seriously injured, or we can not be wearing a seatbelt and be seriously injured. So I took those two probabilities, 0.0616 and 0.0851, and I added them together, and then I divided them. Exactly. We actually have enough information that we could make the second tree. But we don't want to make the second tree now because that's your word a lot of. We've got like 5 minutes. I'd rather spend that time looking at the last piece of this. So answering questions. Because it takes a second to look at it. Okay. Go ahead, Hannah. If you have more space, I mean, it's more, I can make it more organized. I tried to give myself more space, but it didn't really work. Yeah, this this is the first time I've tried to do it all on this screen like this, and I will fully confess to you that it is uh, not an ideal way to do it. I know, but I wanted to be on here so that it could be recorded. I know. Not that I've seen, not that I've figured out. My suggestion to you is this: remember this formula, because this formula is the one that is the base of everything, right? We found out what we needed, and that's what the P of seatbelt complement given seriously injured was. And using this formula, I found the two things that I needed to know, right? I needed to know the probability of not wearing a seatbelt and being seriously injured over the probability of being seriously injured. And then from there, I went, I know that I can make a tree diagram to find those two pieces of information that then need to be divided. So let's just take like a minute here and just do a quick like review of what we did. Okay. The first thing that I would do is find out what you need to know. Use your notation to find out what you need to know. In this case, what's the probability that a driver who was seriously injured wasn't wearing a seatbelt? I converted that question into my probability notation, right? The probability that given we were seriously injured, what's the probability that we weren't wearing a seatbelt? I then used that with my conditional probability formula to find out what I needed to know. The things that I need to know to answer this question are the probability of not wearing a seatbelt and being seriously injured, and I need to know the probability of being seriously injured. Then I made a list of everything that I knew. I knew that the probability of wearing a seatbelt was 77% because a recent Maryland highway safety study found that 77% of all accidents the driver was wearing a seatbelt. I knew that given you were wearing a seatbelt, you had a 92% chance of not being seriously injured. And I know that because accident reports indicated that 92% of those drivers escaped serious injury. And when they say those drivers, they're saying those drivers wearing a seatbelt. Okay? Given condition they were wearing a seatbelt. But then I also know that the probability of not being seriously injured given not wearing a seatbelt is 63% because only 63% of non-belted drivers were so fortunate. Found out what I needed to know, made a list of everything that I knew. I then used that information of what I knew to create a tree diagram. And notice that I labeled everything on this tree diagram, right? I didn't just go down the branch I needed. I labeled everything. And I found the branch that I needed for the numerator. That was a single branch, that one right there. Then to find the probability of being seriously injured, I found those two branches, added them together, divided. Homework, finish your chapter 15 though, okay? We'll do another reversing the condition question on Monday. Your homework on Monday will be to try a couple of them, right? But I want to do one more together in class. So finish your notes.